Good morning, good afternoon, good evening, depending on where you are in the world, and welcome to today's SecurityBoulevard.com webinar, brought to you by Techstrong and Secure Code Warrior. My name is Cody J. Brown. I'm the host of Techstrong Learning. We have an exciting presentation ahead, but first I have just a couple of housekeeping notes. First, today's session is being recorded, so if you miss any of our discussion or you'd like to rewatch, the on-demand recording will be made available shortly after we conclude our live webinar today. If you have any questions, we want you to send those in using the Q&A tab on the right side of the screen. And for any other general comments or thoughts, we want you to use the chat tab. We have also included, there's a handout there available to help aid in today's information, so feel free to download that at your own leisure from the handouts tab. And before we close out, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around. Our topic today is challenges and opportunities for improving secure coding practices. And joining me is Pieter Danhieux, co-founder and CEO of Secure Code Warrior, and Matias, Madou, co-founder and CTO of Secure Code Warrior. So Pieter, Matias, thank you for being here with us. I'm going to turn the floor over to Katie McHugh, who will be moderating today's conversation. Thank you all again for being here with us.
So I want to say a big welcome and thank you so much for joining the webinar today on the challenges and opportunities to improve secure coding practices. We've got a lot to show you today and we hope you have a lot of fun. My name is Katie McHugh. I'm a content writer for Secure Code Warrior, and I'm joined today by two of our co-founders and executives, CEO Pieter Danhieux and CTO Matias Madou. Also joining us today is Nathan, and he is principal engineer at Secure Code Warrior, who's also one of the founding members of the company. We thought it'd be really interesting for him to join from the perspective of a developer as we go through some of these developer issues and challenges. And welcome once again to you all. For those of you tuning in, we would like to get your questions and comments, so please drop them in the Q&A function of the platform and we'll get to them at the end of the session. If we do run a little short on time, we will get back to you via email, so don't be afraid to tell us what you need and what you want to know. So welcome everyone, and we'll kick off now and start sharing. So if we kick this one off today by looking at some of the repercussions of software vulnerabilities, it'd be really, really good to get your perspective on one in particular, and I'll throw this to you, Matias. And this one is the colonial pipeline. Yeah, colonial pipeline attack. So I know that this one, there were several issues that all culminated to result in a really terrible ransomware incident. But would you like to maybe kick us off with that discussion?
Absolutely. Thank you, Katie. So colonial pipeline, interesting one, very interesting one, because if you think about it, a pipeline, it moves stuff. And back in the day, you had to manually open the pipe to make sure fluid is going from one place to another one. Over the years, we made it more, computerized, and we made sure that valves open and closed automatically. And and behold, we actually connected that to the internet. And there's nothing wrong to connecting all these systems to the internet as long as we make sure that the software that is built to open and close these valves ultimately is secure. So colonial pipeline, the specifics here, colonial pipeline is something that runs from the south of the US all the way to the east and the north, and it actually moves jet fuel to certain places into the US. Again, over time, it became more computerized, more software is involved. And unfortunately, the software that was developed for the colonial pipeline wasn't always correct. A couple days before they got hit, there was already an extract of gigabytes of data from the company itself, and information was leaked to the public. The day itself, there was some ransomware that kept them hostage. Ultimately, they paid the bill, but it took a long, long time to essentially reverse the ransomware. What was the problem? There was multiple problems. Let's get that straight of a fact. There was multiple problems, but one of them was SQL injection. One of them was SQL injection, which was populated through another system to the colonial pipeline and was part of the infrastructure. So over here, what I would like to recommend, of course, small problems, coding problems, led to a gigantic problem. Fuel was not able to travel through the US and to the right places. Essentially, it's even worse than that, right? Think about it. If these valves are controlled by an adversary, that can be very, very devastating and problematic. So ultimately, my recommendation is here, build security and build secure systems, or stuff like this can happen. Back to you, Katie.
Yeah, so it's interesting because there's 5,500 miles of pipeline that was compromised as a result of, like we said, a few factors, but essentially one line of code allowed, VPN to be breached, and then everything else sort of tumbles like a house of cards after that. So it's pretty crazy to think that it's just these quite common mistakes that can lead to such disaster, which is even more alarming when there are statistics out there and studies done, one of which says that 48% of organizations admit to shipping vulnerable code. Pieter, do you have any thoughts on that? Because it seems like it's an enormous business risk. Obviously, Colonial Pipeline's just one of many examples.
Yeah, exactly. I think shipping vulnerable code is it's something that happens. It's been happening for I think the past 20 years, right? And I think I think about a few months ago we had Log4Shell coming out around December. I think that's on the next slide, Katie. And I think what has been consistently there in the last 10 years, that is a vulnerability that screws over somebody's holiday. And I think we had the Blasterworm back in 2011. We had Log4Shell December last year. And it's one of those weaknesses that scares every single cybersecurity professional on the planet. Because once you kind of combine code execution with remote, with unauthenticated, that means worms are going to basically travel the internet very quickly. Now, Log4Shell specifically, it has to do with a logging library that is being used by Apache, and it basically parses data that's coming from systems. But one of the problems there is that sometimes these log libraries, when they parse, they have special variables and they take untrusted input, and it had a code execution problem. And that means that anything that was logging things in the background, that was parsing untrusted user input, could actually be used to have a code execution on a system. Now, this was one of those packages of libraries that's been created by somebody, and that's been reused and used like millions of times by devices that were running web servers, that were basically Apple was using, Cloudflare was using it, everybody was using this thing, right? So when it came out in December, like immediately, I think within 20 or 48 hours of the patch being released, there were worms out there that were actively exploiting this problem. And the core of it is that, well, we are reusing so much code, and there's libraries that are being used in so many locations that if there's a problem with that library, that you suddenly have millions of devices that are vulnerable, which we've responded on it really good, right? But I think the problem is patching all of those devices really, really quickly was the hard thing here, because I think even today there are systems that just cannot be patched remotely, or that are still running vulnerable versions of Log4Shell. And I'm pretty sure, I'm hoping not, but I'm pretty sure this year we will have another one of those coming up to Christmas.
It does seem to be the annual gift that nobody wants. But I think I did read a statistic recently. It's something that is like 30+% of instances are still live and vulnerable with Log4j. So that's a little bit disturbing. But perhaps get your thoughts on this, Natan. In a situation where you do have a dependency like this that's incredibly vulnerable, what's that like to deal with as an incident, and how would you respond to this?
Yeah, so obviously the moment that this exploit was known, we've taken a look at all our systems immediately and see if any of our systems were vulnerable. Lucky enough, we were not using the Log4j library to do our logging, but nonetheless, I think responding to this means opening all the repositories that you have in your organization, going through and see which dependencies or like dependencies that you have and transitive dependencies that then use log4j are there, and see if you can disable the library, if you can switch to something else. In this particular case, what was exploited, and is something that I always find difficult, is when you do a log statement, is concatenating user input inside the log. I'm more a fan of structured logging, where essentially we don't format the message itself with user input. We just pass that along and then use JSON or something else, and is not interpolated. And so even though if you were using log4j, it could be that you're not vulnerable if you are using these practices where you don't add user input to the structured message. But still, it was an extremely horrible exploit. But this could be tackled in multiple layers. But the best thing, obviously, when something like that happens is patch every application that you have, try to deploy it as soon as possible, the new version, and also see if we can have other layers in between to mitigate the impact.
Yeah, absolutely. And it's interesting, the statistic with 48% of organizations shipping vulnerable code. I mean, we will address this in later slides, but our study actually found that the same amount of developers knowingly shipped vulnerable code as well. And we know that that's for a variety of reasons, and you know, we will get to that. But it'd be interesting to get your thoughts on the developer experience with these sort of things later on. So we'll come back to that one. Okay, so Pieter, I might get you to go through what we're doing in cybersecurity and what we're essentially not talking about enough.
Well, yeah, I think we'll come back to some of the statistics, but I think like there's still this gap between developers and security. I think for the past 20 years that gap has existed, and how do we close that gap? How do we make sure that developers starting speaking security language and security people start understanding what the challenges are that developers are kind of sometimes facing with? But in general, I'm convinced that every single developer should have at least some basic hygiene in how to build safe and robust code. And I think people that have heard me talk before, I always kind of make comparisons with civil engineering and building bridges and houses, and a profession that's 2,000 years old, right? The first bridges and houses we built were probably very insecure and were causing problems. Nowadays, that doesn't happen anymore because we've kind of learned from all of those mistakes. And I think in software engineering, it's a very young profession, right? And I think we're still going through that transition. We need to make sure that the basic hygiene is known and applied by anyone that kind of touches code.
Would you say that's similar thoughts for you, Matias?
Maybe to add to that, if I can pick it up from where Pieter left it, if you look at civil engineering, if you look at doctors, if you look at all the other industries, you know, there's a lot of certification going on. People need to be vetted. Interesting enough, you know, there was no software involved, 20, 30, 40 years ago into these areas. Slowly but steadily, software becomes part and becomes essentially even the critical part of all of these things, of engineering, of doctors, of everything that we do on a day-to-day basis. So interesting enough, software took over. And, even more interesting is that stuff like, skill building, certification, there's quite often not enough attention to those areas, to the people aspect of, hey, who's building software? So I agree 100%. We need to learn from other areas, and we actually need to copy what works in other areas to our area.
Okay, so let's jump straight into some of the finer points of our research, and I'll go through some of the details there on how this study and survey was put together. It delves into the key insights and experiences of 1,200 active developers, and they're placed globally, and it's to understand their skills, their perceptions and behaviors when it comes to secure coding practices, and their impact and perceived relevancy in the SDLC. So the survey respondents included managers from within the development community as well, and active software engineers and people who are actively coding to create new software and applications. I think just about everybody in the industry would agree that it's been an uphill yet essential battle to create an environment where the goals of the security team and their developer counterparts are aligned. That seems to be just this a never-ending conundrum to solve, where we've still got so much to go before we're truly there, and especially with organizations that are looking to move away from sort of legacy methodologies like waterfall and even agile these days. And we know that there are a lot of organizations just aren't there yet. And we know that there's different maturity levels that people are contending with. But the session is going to take through some of these findings, and it will point to some pain points where they'll probably be recognized in a lot of teams, and they're things that can be overcome. So we'll look at what developers prioritize and why they do that, what current secure coding practices are being adopted, and why they might be problematic. And it's important to note that this should also reveal that it's really the fault of the developer as to why secure coding isn't ingrained in their DNA and in their software development process. So let's... Okay, so I might start with Matias. One of the headline findings, and it's one of the things that we've talked about quite extensively, is that just 14% of developers consider security a priority when coding. Do you have any insights into that?
Sure, and I absolutely, I would love to go a little bit through the upper right statistic here and maybe group it a little bit together. If you look at the number 1 and number 2, which are both 19%, code quality, reduction of technical depth, application performance, it has a lot to do with rework. And I would assume as a new developer, if you join an organization and you ask a developer, what do you want to do in an organization? I'm pretty confident not the first thing they will say is, hey, you know what? I want to do rework. I want to optimize code. I'm pretty confident they want to say, hey, I want to work on real stuff. I want to create features, functions. I want to solve real problems. So interestingly enough, the third and the fifth one over here is about what the developer is actually desiring for if he or she is joining an organization. Number 1 and number 2 is really about rework. Interesting. It means that we do not have it right from the start. Something is missing. Do we miss knowledge? Of course, a product evolves. Don't get me wrong, and the technology evolves. But still, there's a lot of emphasis on rework. So number 3 and number 5 is about new features, new functionality, creating something new into the organization. Number 4 over here is really around application security. So it is only 14%, but I would assume there's also a good reason. There's plenty of people that go with a desire to create new functionality. And, well, security is quite often an afterthought, especially for new joiners into organizations, new starting people. It is an afterthought. Why? Because, well, when you start as a developer, you're not always considering every possible execution of your application. It's only when you're a seasoned developer that you start to realize, oh my God, people are misusing my code. They're doing something different with my code. And that's when the developer starts to realize, like, oh my God, security is really, really important. So these are my thoughts on the top statistic here, Katie.
Yeah, it's interesting with almost 1 in 5 survey respondents saying that code quality and is and reducing technical debt, obviously, which is a little different. But with code quality still not being synonymous with security, that's probably another hill for everybody to climb. But I did think that was interesting that they're still seen as separate from one another.
Yeah.
Would you say that that's still the case?
I'm sorry, was it for me?
Pieter?
So I don't think it should be. I think if we talk about quality, it should encompass security. It should encompass, speed. It should encompass a good code. Security is, however, super important because it can give you a lot of exposure into the world if things do not go right. If the speed of your code isn't really optimal, is suboptimal, well, people may complain, but you're not going to make the headlines of the news. If security is not properly done, you may actually make the headline of the news.
Yeah, very true. Nathan, would you say that this rings true for you in your experience?
Yeah, definitely. I think that code quality and security is intertwined to some degree. So if like code is usually split up in like the business domain, like the logic of the application, then you have the lower level stuff in the code where we communicate with a database and so on. And when we talk about high code quality, it probably means that it is easy to read. It probably means that it's well tested. And if you build code like that, there's a lot less chance to have these typical logical flaws in the code bases. So I think that they are definitely intertwined to some degree. However, when we touch on different parts of the application, let's say that we communicate with a database. If you have never seen how an injection flaw gets executed, then you wouldn't be able to spot that in the code. So even though the code quality would be high and everything would be well tested, you wouldn't test for that specific case where a vulnerability could be present. So I think that if we give the developers more education on security, it becomes more and more like a single effort where code quality encompasses everything from application security. And I like to see this more being done in a real world environment where tests for that we do currently, like functionality tests, that we also test for security while we are developing new software.
It certainly helps bring it into more of a priority. That's awesome. So I might go to the next slide, and Pieter, we'll get your thoughts on this one. So when asked what organizations prioritize, 41% said that their organization prioritize security over functionality. And that's really reassuring to hear. And application security is expected to increase in importance over the next 18 months, according to 66% of respondents. But managers again rated the performance as the area of focus over the next 18 months. So why would you think that is?
Yeah, it's one that I'm kind of thinking about myself a lot, because like we are a software company with a lot of people that are writing software, but we're also a company that values security very highly. So I think in personally for our company, like functionality and security are probably very equal, because I think the value of the new features is important for us as a business. But also the value of being seen as a company that's setting a standard for security is really important. Now, I can imagine that that's not the case in every single industry and vertical out there. I think there are verticals in banking and technology and telco mainly, I think, are verticals where getting functionality out is important, but there's of equal value is making sure that that application is performant, doesn't have bugs, has a good user experience, and is kind of not exposing any customer data. But I think there might be verticals that are a bit trailing behind, where that balance is not there, right? Where it's all about shipping, and less about shipping it in a secure way. Now, I think the amount of not only breaches we've had on the market in like seeing increasing over the past 10 years, like it's been exponential, will be driving every single vertical to care about functionality and security equal. I think the second thing that's driving that on the market is going to be regulations. We started seeing that in the US with President Biden, with NIST, with the executive order, where now there's kind of regulations pushing, saying, hey, whatever software you're shipping, you kind of need to make sure that you care about the software security of it. And I think we're going to see that more and more in the future. And there's going to be more governments are going to do that. More verticals are going to push out things to say, hey, we want to make sure that the consumers are actually trusting our IoT devices, are trusting our cars, are trusting our toys that are all kind of running on software. And that's why I think there is this conviction that people know that cybersecurity is not going to go down, or is not going to become less important in the next few years because of what's kind of happening around the world.
Absolutely. And I guess when you going back to that regulatory component that's sort of pushing this along, financial institutions, BFSI, that vertical seems to be, looking to kind of pave the way for better security practices that are sort of influencing the rest of the industry, which is good to see. Okay, so Matias, do any of these findings surprise you at all?
Somebody is missing a party over there with the piano. So it looks like, so it doesn't surprise me. So 66% of respondents started application security is going to increase in the next 12 months. I can actually, give you my perspective over here, and I'm not sure if it's correct, but there's a couple of evolutions in the last months, where there's Corona, there's COVID, more people are working from home. We rely more and more on systems. Not to say that we didn't rely on it back in the day, but there's even more reliance on computer and interconnectivity. That's one stream that is going on. So for sure, I can see why, we're going to increase in the next 12 to 18 months this focus on security. We expect our systems to be secure, right? There's maybe a second thing, and we've seen this back in 2007, 2008, the financial crisis, where when there was an economic downturn, more and people started to figure out ways to have money. Sometimes, they had to do stuff to get money. So there was more crime. Maybe if something like that happens, right now there's turmoil on the markets, it may turn people more to the other side. So, hey, over here, I do see a lot of reasons why people expect to invest more in cybersecurity in the next 12 to 18 months, just from a global perspective, what's going on, not to mention what's going on in Russia, for example. But I would assume there's more and more an emphasis on, hey, cybersecurity is important. We do more things online, more systems come online, more of our critical systems come online as well. Think about our cars. So I do expect on the next 12 to 18 months, just like in the survey, that there's going to be more of an emphasis on building secure systems. Not to mention that didn't happen in the past, but I expect there's going to be more emphasis on it.
Yeah, absolutely. And if we look at the general opinion about secure code and who is responsible, I think that sort of highlights some of the stuff that we've talked about quite extensively on, the challenges between developers and AppSec, with 22% of respondents saying, AppSec's definitely responsible for code security and leave me alone, basically. But I'd love to get all of your thoughts on this particular slide. But let's start with you, Matias.
Well, I would like to start with the right-hand side. Who's responsible for security? And it's an interesting one. So back in the day, 10, 15 years ago, you had the developers and you had the application security team. And back in the day, application security team was calling the code ugly. So they were pointing fingers at developers and saying, hey, you have to make sure the code is correct because here are all these problems. While at the same time, developers said, but wait a second. There's security in the name of your, department. Aren't you responsible for security over there? So they're pointing fingers at each other. Today, these groups are more and more working together. And if you look back 10 years ago, 2 people were responsible for 100 developers. 2 people were responsible for security for 100 developers. So 2% versus 98% that had to do the work. Today, it's different. There's a shift, but I'm still trying to understand, how big of that shift is. Right now, it's still 2 people out of the 100 that are responsible for security. But from the 98 left, I'm wondering, how many of those folks are actually champions that are broadening and saying, hey, within our organization, we want to do the right thing. And if there is need for help, I can always help you out with writing secure code. How many are security aware? How many are security skilled? So the 98 people out of 100, next to the 2 that are responsible for application security, become more and more part of the game. And I think that's the only way we can win in organizations. If we have a group of 100 people and only 2 are responsible for application security, how can we bring the other 98 onto the journey of writing secure code?
Yeah, absolutely. That seems to be the sticking point in a lot of these situations. But Natan, does this sort of mirror your experience as well?
Yeah, so I strongly agree that a team needs to consist of different T-shaped individuals. So we need to have strong engineers in development teams, but also people with a knowledge in application security. And the reason for that is that security comes into multiple levels. So an example of that log4shell would be that there was a vulnerable component in software, and obviously, as a security engineer, if you read the blogs that or the tweets or anything related to security, you would see that notification of something wrong in that library very quickly. You probably have some automated tools to scan the code repositories for these specific vulnerabilities. But if you're part of the team, you probably will ask an engineer to help you resolve that issue, update a dependency. Maybe it will require some code changes. And then on the other side, there are some typical design flaws in code that could be catched, for example, by QA, or could be catched by a product team. And then you also have these typical application vulnerabilities like SQL injection and common injection flaws. So I think security is really a group name of multiple different things that could go wrong with source code in general. So I don't think that saying that application security is responsible for security will ever work, and also not saying that engineering is fully responsible for security will ever work. I think it's always the group effort that will drive this motion forward of secure applications.
For sure. Okay, we may have to dedicate one speaker to each of the next slides, just because we're going to run out of time. But in terms of, this is one of the contradictions that came up in the studies, that developers found that they were, they enjoyed their training and that they had said they had enough training, but it still seemed to be difficult despite having enough training, which is a little bit of a contradiction there. So it'd be really good, Pieter, if you could give your thoughts on this contradiction.
Well, like I think the problem is, like there's no such thing as secure code. Like it's not like a binary switch you can switch on and off because you have knowledge. Like I think writing code that is secure in a very modern language like Rust or Python is very different than writing code that is secure in a very old school language. Old school, but like in C, C++, or COBOL, or one of those things, right? So like secure code in both of those languages is very different. And in one, it might be very easy because everything is already checked in boundaries and everything kind of gets validated and memory is cleaned up and all that kind of beautiful things we do now. And in some, it's actually very hard. So I think that's why we're probably getting a bit of contradictory results here, that we might have people that are using more modern languages say, hey, well, it's actually very easy and we follow training and we get it. But security in other languages might be very hard to actually write as well. I think at least that's what I think.
Yeah, and look, I know that we have touched on this a little as well, but the response that 48% of developers said yes, they do leave vulnerabilities in their code, and we know that not all vulnerabilities are going to lead to disaster, but it still shows that there's not a huge commitment there to the highest possible quality code. So, Matias, could you maybe give your thoughts on that one? I know that we have spoken about it before. But just
absolutely. So, yeah, maybe my one thought is, well, there was this previous study that said it was 46%. We questioned that, rightfully so. We say, well, oh my God, is it really 46%? That sounds like a lot. Well, out of this study, it seems to be even 2% higher. Well, what more can we say? Maybe the one thing that we can say is, what are the reasons? We may question now the reasons. But if people say yes, or it depends on the project, we need to dig into the reasons why they say yes, so that we can address that essentially.
Absolutely.
Yeah, sorry, Kate. I also think it's a bit like asking me the question, "Do you ever swear?" I'm like, "Oh yeah, sorry. Yeah, I sometimes do. Like that's probably one of the responses you get there as well. Like nobody's gonna say that they would never do something wrong, right?
No, and I think that it's, yeah. I mean, it's not really something that you should expect everybody to be perfect, or that you should expect developers to be security experts. We know that that's not what they signed up to do. But it is an interesting statistic in light of the data breaches that we see that are caused by what seem to be quite small problems, at least initially. Okay, so Matias, I might get your thoughts on this one, on the types of vulnerabilities that exist and why. Any thoughts there?
Oh, I'm really going to move that one to Nathan. I think he's very close to the code, and he can shed some light on why these type of vulnerabilities exist and why.
All right. I think that to be good at security, you need to do it often, or you need to take a look at vulnerable code often, and then see how it is fixed. And the reason I'm saying that is because for me, if I look at a piece of software, or even if someone explaining an architecture to me, I already have a gut feeling that where I will be needing to look for specific flaws or vulnerabilities. And the reason is because after a while, you wire your brain to recognize certain patterns. I don't need to have experience with a new NoSQL database to know exactly how an injection flow would manifest through the code for that specific database. I think that many old or known vulnerabilities for a while still exist because of that we've have followed, for example, training once for a day, and then we think that we're security experts, but that's not the case. You need to do it very repetitively so that you start to develop that skill and that feeling when you see some code that could potentially be harmful. Also, one of the things that I want to mention on libraries and frameworks, we tend to emphasize that, for example, not using a library or a framework to get rid of a software vulnerability or whatsoever. But at the end of the day, we always depend on a library. Let's say that we write bare-bone Java, you still depend on the runtime of Java, and that could still be vulnerable. You still depend on the Java standard API, and that could also be vulnerable. So I think a lot of software vulnerabilities exist in code that we just didn't write. And that doesn't mean a new fancy library. It could also be in these core libraries, these core components that almost everyone uses. And I think that's very important, that we try to hold each other accountable for the software that we write and then deliver to each other, especially in these core components, and contribute where we can.
For sure. Okay, so Matias, I know that this one would be near and dear to your heart. So if we look at the top practices associated with secure coding, it does go back to your idea of rework and perhaps secure coding not meaning the same thing for everyone.
So if you would ask me the question, what is secure coding? It would be the act of writing code. It would be the act of using known secure good coding patterns and using secure components. And if we look into the survey, the results, what we see that actually that is way down there. It's only number 6 where it's really the act of writing code, which is surprising to me. Only 29% says, you know what, is the act of writing code that I consider as secure coding. Where the use of secure components came in at number 3 at 32%, which is also close to what I see as, hey, you know what, that is really secure coding. A couple of other interesting pointers in here. The second to last one is, you know what, I'm just writing code and it is somebody else's problem, unfortunately. There's this group called AppSec. Well, probably they need to do that. Of course, not a good answer. But then if you look at the other category, the other answers, number 1, number 2, number 4, 6, and 8, well, they come really close to finding the problem. It is not the act of writing code, but more the verification afterwards, using a solution, looking into the libraries. It's all interesting, you know, it all needs to happen. I'm not saying you should not use a SAST or a DAST solution, or you should not vet your components or look into your code. But what I'm saying, it's a little bit too late. It's a little bit later. Maybe it's a good idea to focus really on the act of writing secure code and making sure people are knowledgeable and they have the right tools and training to produce the secure code. So this is a pretty interesting statistic to me, because at the end of the day, there's not a lot of focus on the act of writing code itself, but more on what leads up to writing code. Yes, by the way, training is in there. On number 4, there is training, education, everything that needs to happen. But still, that is something that needs to happen before you write code, because then you can actually practice what you've learned in the training modules.
Absolutely. And the white paper itself and the survey covers a lot more ground than we'll be able to cover here. And we do encourage you to download it. It's available for download. You can download the report straight away, I think, from the Docs tab. And also securecodewarrior.com, of course. But we might jump through and start talking about some of the recommendations that we would have to alleviate these problems or these attitudes and challenges that you may see in your own organizations. So number 1 would be to define secure coding. Would you like to take that one, Pieter? I don't think we can hear you.
Sorry, I have muted myself for the piano concert that was going on in the background in my house. Defining secure coding, like I said before, it highly depends on the vertical and the industry you're kind of operating and the size of company you are, but what is acceptable for you as an organization to run as a risk? Like how much time and effort and where do you want to invest around secure coding? And I think it's, as Matias kind of said, like many people kind of start at the end with testing and basically getting a bunch of doctors in to try and find what the problem is. Other people are kind of investing into technology that will scan, and I think there are the more mature organizations that kind of do the whole shift left, start left thing, which is around, well, we need to make sure that we write stuff securely from the start. And what does that mean for coding patterns? What does it mean for knowledge that everybody needs to know? Because we don't want to turn every single developer into an expert, but at least we want to make sure that developers have some basic hygiene levels around security, and that they understand what are the good and the bad coding patterns that we should be using.
For sure. And we do talk a lot internally about adopting a cohesive approach to security. So did you want to explain a little more on that as a general recommendation?
Absolutely. So it starts by defining what secure coding is into an organization. And there's things that lead up to secure coding, and there's stuff that needs to happen after code is produced. Quite often what we see, it's a little bit ad hoc what happens within organization. There's not a really structured approach. And that is very clear from the answers of the survey, I would say. If it was very clear what secure code meant, if all the concepts were clear what had to happen, I would assume there would be a little bit more of a shift to one focus or one answer in these questionnaires than have a broad distribution. So adopting a cohesive approach to me is, first of all, define what it means in your organization, producing secure code, what the standards, what the regulations are, but then also define a cohesive approach on what leads up to secure coding, build out a program, an upskilling program, do the act itself of secure coding, but also defining what happens after the code is produced. SAST, DAST, name it. Or actually, by the way, it should be also in the act of writing secure code. Rapid feedback cycles becomes very, very important these days. So that's what I think about a cohesive approach to secure coding.
And Natan, I mean, we do see some barriers to adoption here. One of the big ones is developers not having the time needed to train and implement things. But do you have any quick thoughts on that one, Natan?
Yes, I think it's something that as like an entire business needs to strive towards is produce secure software. So let's say that you need to add a single form element to an old application, and the old application is deprecated framework. Would that mean rewriting the whole thing to make sure it is secure from now on, and then continue with a modern framework, or does that mean just adding that single feature, right? And that is a business decision that happens a lot during software development. Is it will we invest time in doing the rework, making sure everything is up to date, or will we just simply hack in that specific feature? I'm very lucky to be here at Secure Code Warrior, where we don't need to make that trade-off. maintaining our systems and keeping everything up to date and using the latest is business as usual. But as Pieter already mentioned earlier, that's not everywhere the case.
Thank you so much, all of you, for joining. And thank you so much to our audience. We did get some questions, but we will answer them via email. We've got to wrap up now, but tweet us at SecCodeWarrior. We're always looking for more friends there, and we'll catch you for the next session. Thank you so much.
Thank you. Thanks for.
So like Katie said, the survey can be downloaded from the handouts tab, so feel free to grab that if you like. But thank you to Katie, Pieter, Matias, and Natan for joining us. I'd like to remind our audience that this session was recorded. So following this webinar, you'll receive an email with a link to access the recording on demand. You can also find the recording living on the Security Boulevard website. Just visit securityboulevard.com/webinars and be sure to look in the on-demand section. So on to the 4 $25 Amazon gift cards. Our first winner is Margaret L. Our second winner is Dan W. Our third winner is Lynn A. And our fourth and final winner is Benny Y. So to the 4 of you, congratulations. Keep an eye on your inbox to claim your gift card. But if you don't see an email, just check your spam folder. So thank you to Secure Code Warrior for sponsoring today's webinar. We couldn't have made this possible without them. Our panel members, thank you so much for being here. And to our audience, thank you so much for joining us. We ask for one extra moment for a brief post-webinar survey that should pop up on your screen here in just a moment. But otherwise, we hope to see you at an upcoming Techstrong Learning webinar. Everyone have a great rest of your day.